a mysterious gas has been discovered in our solar system from another star. An object has arrived that astronomers have named 3AIC. But what is it? Just an ordinary comet or a controlled spacecraft from an extraterrestrial civilization? Such an opinion has been voiced by the well-known astrophysicist Avi Loeb. And will this enigmatic object come into contact with our planet Earth? Let's find out. This is not your usual podcast. I am Astronomer Orion Vega. Let's begin. Astrophysicists have found in this extrasolar object signs that could resemble a controlled spacecraft. My friends, every time an interstellar visitor enters the solar system, and this is already the third one we've spotted, Avi Loeb presents it like a detective story. On July 1st, 2025, the third interstellar object was registered. We've spoken about it before. It is known as 3I Atlas. So what is unusual about this third object? First, it was discovered, fortunately, quite far from the Sun, really near Jupiter's orbit, even slightly beyond it. That's rare. Comets, as a rule, don't like to reveal themselves so far from the Sun. Out there it's cold, and they don't normally evaporate. But apparently if this really is a comet, and let's stress the word if, since Loeb claims it's not a comet, most astronomers still lean toward the comet explanation, and if it is indeed a comet, then it must be quite large, because telescopes can detect it. That means its body is big enough to reflect sunlight and be visible to instruments. Second, the strange tail this comet seems to have may not be a tail at all. Loeb and his English colleagues, who published a paper on this, pointed it out. Perhaps it's just a photographic artifact. Maybe the body simply moved while being imaged, stretching the light into a smeared line that looks like a tail. What about its size? We don't know for sure. If it's not a comet, then it's a rather massive body large enough to reflect substantial sunlight, possibly around 20 kilometers in diameter. But if it is a comet, and has already warmed up enough to begin releasing gases, then it surrounds itself with a temporary atmosphere, called a coma, which makes it appear larger. In that case, the actual solid nucleus could be much smaller, perhaps only 1-2 kilometers across. Right now it's still far away, so the data remains unclear. Another detail that caught the attention of the American and British research group, let's call them visionary thinkers, because sometimes good science fiction is worth considering, was the orbit itself. The plane of entry of this celestial body almost exactly matches the orbital plane which the planets of our solar system move. Nearly all planets, including Earth, orbit within this same flat disk we call the plane of the ecliptic. The trajectory of the intruding body, Atlas, lies almost perfectly in that plane. It creates the impression that this object seems inclined to encounter the planets of our solar system. Its trajectory deviates by only about 5 degrees. The probability of a close meeting isn't very high, but it's not zero either. Actually, I would argue with Avi Loeb and his colleagues. They write that the probability is less than 1%. I calculated roughly 5-6%, maybe about 6%, but it's still small. I agree, a small probability that the object didn't come from some random angle, but rather almost, like when you skip a stone along the water and it starts to bounce. That's roughly the kind of shallow angle this body entered at. The second peculiarity, it came in the direction opposite to the rotation of all the planets in the solar system. All the planets and the Sun too, if you look from the North Pole, rotate counterclockwise, while this one came in clockwise, so it is flying head-on against the planet's motion. How strange is that? Here I completely disagree with Loeb, who says that is a less than -1% event. That's simply not true. It's a bit awkward to argue with experienced astrophysicists, of course, but the probability of that is exactly 50%, either with or against the clock. It depends on the impact parameter. There's nothing more to say about it, yet they think it's unlikely. But coupled with the fact that it moves almost in the plane of the planet's motion, it really is an improbable occurrence. Moving along, I'll quote the astrophysicists directly. A close flyby of 3 planets precedes this body, literally in the next 2 months, 2.5 months in August, September, October. This very fast object, moving at roughly 60 kilometers per second, will pass quite near Mars. It probably already passed by Jupiter just days ago, fairly close. Not close enough to hit Jupiter, but quite near, very near Mars. So, even the probes currently orbiting Mars will photograph it for us. Although their optics aren't huge, the encounter will be very close. And this is important to say, if this body is not natural, but a spacecraft controlled by someone. Then while flying past Jupiter and Mars, it could perform a turn. They call that a gravity assist maneuver. Under the planet's gravitational influence during a flyby, you can slightly change your subsequent trajectory and potentially swing past Venus. 3 such close approaches would be an unlikely event. Why go past Venus? Because after that maneuver, you could also get closer to the Sunday. We already know how to do these sorts of things. The Parker spacecraft, for example, is planned to approach the Sun to study the inner corona. It deliberately flew several times past Venus, which slowed it and threw it closer to the Sunday, so we can perform those maneuvers too. There's no need to be impressed on behalf of interstellar visitors. The spacecraft would be doing what we've already learned to do, if it is indeed a spacecraft, as Loeb and his colleagues hint. If all of this works out, if it is intentional, then this visitor might not leave the solar system, way Oumuamua and Comet Borisov did, but could remain within it. Gravity assists are not only capable of accelerating and redirecting a spacecraft's path, they can also slow it down. It all depends on how you approach and which trajectory you choose. But why would this visitor want to settle into a near-solar orbit? The fact is, by moving within the plane of the ecliptic, this cosmic stranger could, in theory, cross paths with Earth. And here the scenario begins to sound like pure science fiction. In the scientific paper, the authors openly mention the dark forest concept from Yu Cixin's famous science fiction novel, as well as the classic Fermi paradox. Where are they? Well, perhaps here is the answer. If, and it's a very big if, this object were artificial, one could indeed speculate that its planned gravity maneuvers are intended to bring it close to our planet. On the other hand, if it is a natural object, then we are unlucky. Not only would it fail to come near Earth, but it would pass so far away that astronomers would struggle to study it properly. At the time of its closest approach to the Sun, Earth will be on the opposite side, and the Sun's glare will blind our instruments. In that case, we wouldn't be able to observe it clearly at all. But if the intention is a meeting with Earth, we should look to the end of November or the beginning of December this year. That's when such an encounter could occur. Very intriguing. Avi Loeb and his colleagues themselves emphasize that this is meant as a didactic exercise, a way to demonstrate what computational astronomy can do in predicting the trajectory of a celestial body. If it were artificial, yes, as a teaching example, it's clever, but it might also turn out to be correct, and even a strategy for an interstellar visitor. Only days remain, perhaps a couple of weeks, before more observations are processed and published. Then we'll finally learn whether this is a comet or something artificial. If it's a comet, we'll see a tail, a coma, and the usual uncontrolled flight. But let me add a more imaginative thought. What if this object is artificial, disguising itself as a comet? It could easily shroud itself in a gaseous coma, even eject a dusty or smoky trail. After all, on Earth we know countless military tactics that involve smoke screens and decoys. We must look very closely. Is this truly a comet or a cosmic visitor hiding under the mask of one? The object 3AIC is by no means the first that Loeb suspects may have an artificial, extraterrestrial origin. One cannot deny that each of the 3 interstellar objects spotted in the solar system in recent years carries unusual traits. Let me remind you, in 2017, scientists registered the first interstellar object within the solar system. The certainty that it was not native, but arrived from afar, is based on its speed. The Sun, massive as it is, cannot hold on to bodies moving that fast. Objects native to our solar system travel at moderate speeds, but if a cosmic body approaches us from deep space, one that never belonged to the solar system, it can arrive at virtually any velocity, from tens to hundreds of kilometers per second. The Sun cannot hold on to such an object. It will rush past and continue its journey into the galaxy. That is exactly what happened in 2017. Surely you remember the name Oumuamua. Every astronomy enthusiast recalls it quickly. It was the very first interstellar object ever observed, and it was full of mysteries. First, no one could explain where it came from, why it was the first, and why astronomers had never registered anything like it before 2017. Second, as it departed, it appeared to gain speed, as if it had switched on a rocket engine. Avi Loeb was among the first to call attention to these peculiarities. To be clear, he is a respected astrophysicist. He teaches at Harvard and even heads the astronomy department there. But he was so fascinated by the unusual properties of this first interstellar visitor that he collected all the data and presented it as a puzzle. In science, after all, A puzzle is a wonderful motivator for further research. Unfortunately, we discovered Oumuamua too late. It was approaching Earth from the direction of the sun, and astronomers rarely point their telescopes toward the sun because of its blinding light, so we only noticed it when it had already passed by Earth and was leaving the solar system. That left us no chance to chase it and very little time to study it, till we learned a few things. First, its shape was unusual, a couple of 100 meters long but only a few dousing meters thick. It gave the impression of being cigar-shaped, reminiscent of the spacecraft we see in science fiction films. Second, it really did behave in a way that defied Newton's laws. When it passed the sun, instead of being slowed, it gained extra speed. Yes, the sun did decelerate it somewhat, but it was as though hidden thrusters had fired to accelerate its flight, yet no exhaust, no gas plume was detected, and it didn't resemble a comet either, since comets release jets of gas when their surfaces evaporate under sunlight. This was more like a typical asteroid, though not entirely typical. Out of the 1.5 million asteroids discovered in the solar system, not a single one was cigar-shaped, yet this first interstellar arrival already displayed the bizarre form. Loeb suggested it could be an artificial object, perhaps a spacecraft, or perhaps just interstellar debris fragment from a distant planetary system that wandered into ours by chance. You know, to be honest, I've always doubted the idea that Oumuamua was just random debris. Its trajectory was very unusual. It passed by all the planets of the solar system, then dipped inside Mercury's orbit close enough not to be scorched by the sun's rays, but close enough to recharge solar panels. If it had them, it gave the impression that its path had been calculated in advance. Avi Loeb noted this as well. Only 2 years later, in 2019, the first interstellar comet was registered. This was discovered by astronomer Avi Borisov, and it became known as Comet Borisov. It was officially given the second interstellar designation. By convention, I stands for interstellar, so the first object, Oumuamua, was 1I, and Borisov's comet became 2I. After that, astronomers wait some even expected new discoveries every couple of years, but nothing appeared for 6 long years. Finally, on July 1st, 2025, the third interstellar object, 3I Atlas, was confirmed. Fascinated by the possibility that Oumuamua was artificial, Loeb went further. He suggested that similar objects may have passed by before, unnoticed. That's actually a reasonable assumption. We still don't monitor the entire sky continuously, and only now are robotic telescopes beginning to make that possible. Out of the 3 interstellar objects we know of, 2 were discovered by automated surveys, and 1 Borisov's comet was found with a homemade telescope for professional astronomy. It's a little embarrassing. It shows how much we've missed. So Loeb decided to investigate whether there had been earlier cases. He turned to the records of meteor patrols. These are networks of cameras that constantly photograph the night sky and track meteors. If a meteor is captured by multiple cameras spaced far apart, astronomers can reconstruct a 3D trajectory to determine where it came from and where it fell. Among countless meteor tracks, Loeb identified one that showed an unusually high velocity. As I mentioned before, objects don't move that fast within the solar system. It's like a car speeding through a sharp turn. If it doesn't slow down, it will fly off the road. Likewise, if a body moves too fast, the sun can't hold it. That meteor track strongly suggested an interstellar origin. Loeb then asked, if such objects enter Earth's atmosphere from time to time, why not look for their remains on Earth? Most burn up, of course, but a sufficiently large fragment could survive and fall to the surface. This particular track led him to conclude that the remains of such a body might have landed in the Indian Ocean. The approximate location was even calculated. Loeb raised the money, found sponsors, chartered a small vessel, and went, or rather sailed, to the spot where the celestial object was calculated to have fallen into the ocean. He deployed a special dredge equipped with magnetic gear to search for magnetic remnants of the meteorite. Generally speaking, meteorites are magnetic. Iron meteorites, and even many stony ones, are noticeably magnetic. Their iron content can be on the order of 5–6%. And if it were a spacecraft, you'd certainly expect metals. True, aluminum isn't magnetic. In short, Loeb found small metallic spherules on the floor of the Indian Ocean. When the body barreled through Earth's atmosphere at high speed, it heated up. It partially evaporated. As physicists say, surface ablation occurred, turning material into tiny droplets of metal that fell along the trajectory to the seabed. The composition of that metal is unusual, At least according to Loeb. He's trying to prove it. Not everyone believes him. He can be over-enthusiastic and sometimes reads wishful thinking into the data. But he's a scientist. Not all meteoritic experts are convinced this is extraordinary. They point out that iron meteorites with similar chemistry do exist. Loeb insists the composition is rare and uncommon mix of metals, those little spheres, and that this is evidence not only of an extraterrestrial origin but of an extrasolar one, that the body came from another planetary system with a different meteoritic or even manufactured composition. That is how far his initiative on searching for extrasolar visitors went. It's remarkable. He didn't stop there. He pushed the story forward to its logical implications, and now many others have taken up this line of inquiry. I think we will regularly receive reports of interstellar finds, because in the coming years, astronomers will monitor the whole sky and won't miss anything interesting.